I put this together last night because the person from India who was supposed to give a talk on AI is ill, so he couldn't do it. So I thought rather than AI, everyone wants to hear about Pomodoro timers, surely. So tray timer per Pomodoro. That just means 3 tomato timers. So I'm just going to walk you through my experience with Pomodoro timers. So it's just a simple little project. But the basic, so this is an ancient technique developed in late 1980s. So the way it works, so this was originally developed for, these timers that you get in your kitchen that sort of like time how long the oven's been on and you're cooking eggs or whatever. And you set it for, pick your task. You set the timer for 25 minutes. You work on the task, and when the timer goes off, you take a 5-minute break, do whatever you want to do. You repeat that 4 times, 25 minutes, 5-minute break, and then you take a longer break, sort of 15 minutes. So the idea is that you are concentrating properly on what you're doing. You're not constantly looking at your phone or checking your watch or whatever. You're just sort of working away because it's only 25 minutes before you take a break. So I found it really helps your concentration, actually. Otherwise, you're constantly just fidgeting or checking your phone or whatever. So that's the idea. So I guess it was a few years ago now, Romilly Cocking, who joins us quite often, is not here tonight. He created something what he called Lazydoro. And the original idea was when he sat down on his chair in his office in front of his computer, you wanted a timer to start and time out 25 minutes and then flash at him or buzz at him and let him know it's time for a break. And then he goes off for his break. When he comes back, the timer starts automatically as soon as it sits down. And he was struggling with that a bit because he couldn't reliably get the cushion to detect that he was actually sitting down or whatever. So I had mentioned on Facebook that these time of flight sensors are really good. So there's VL53L0X. They cost about 2 or 3 pounds. And the way it works is it sends out a beam of infrared light, bounces off something, and then it receives at the receiver end. And it calculates how long that took. And then that gives you the distance to whatever object you're looking for. So I use one of these in my my water softener to detect how much salt is in the hopper. And Romilly was using it for detecting if he was sitting in his chair or not. So this was pointing towards him and figuring out how far away he is. And he's within a certain distance. Then he would start the timer, and these LEDs, neopixels, would count down so he could see. He just got 1 neopixel left to finish his Pomodoro. And when it finished, this buzzer would go, and then he could walk off and go have a tea or whatever. And and then when he comes back, the timer starts again. So, sort of a clever way of doing it. So I started looking into it. I was just having trouble concentrating one day, and I thought, well, let's just try this Pomodoro thing. So if you go to one of these websites, they just do that Pomodoro all for you. So just click on the button, and you can set up the tasks you want to do and things like that. And then you just play it and pause, etc. So I thought it was pretty cool, but I just wanted to build something. So I built 2 of them. So there's this Raspberry Pi PICO W here on top of the banana. And so that was the first version. And then I built a more complicated one here using the Raspberry Pi. And one thing that showed me is just how, it's good, gives a good contrast between the 2 systems. They are quite different, as everyone knows. But it was just interesting just to see, how you do each one. So the PICO W one first. So I did mostly just use exactly what the code that Romilly had. He had posted it to the GitHub. I I grabbed the code, made a few modifications, hooked up the screen, and got it working relatively quickly. This one counts up instead of down, but that doesn't really make much difference. So this is using a PICO W on the back there, and then this is a Pomodoro or Pomodoro PICO display. So I think the PICO W is about 6 pounds, I think, and the display itself might be 8 or 10 pounds or something, maybe 12 pounds even. But luckily, they are really good screens. I mean, there's nothing special, but you do get it with a NeoPixel, and you do have 4 buttons that come with it. So they make it really easy to build with. You just take the Pomodoro firmware, you put it onto your PICO W, and then you're up and running. So I did this whole little project in the space of a weekend. It's sort of like a day and a half or something, just playing around. So that was, yeah, very simple. So you just only have, I think, go at start, reset, a few minor things like that. It's all using MicroPython, and it gets a little bit. There's not very many easy improvements you can do. Like there's limited number of fonts available and printing graphics and all that sort of stuff. You can do all that on this kind of system, the Picos, but it's a lot more work than doing it on the Raspberry Pi. So this is the Pi version. So there's a Pi Zero W2 behind there. It's a bigger screen, but it's also Pomodoro Display Hat Mini. Again, you got the 4 buttons and the LED. This yellow bit structure here, it just connects. So it's a tool, or it's a toy, something like Lego. Just build more robust structures than you can with Lego. And this uses Python. So it's the same idea. Sort of countdowns. This one counts down. So it starts at 25 minutes when you start, when you first powered on. It counts down, and every minute the phase of the moon changes. So there's something like 23 different phases of the moon. So just every once in a while, the moon will just change slightly, going from, you know, a dark moon to a full moon as time goes on. Obviously, it's got a clock up there, so date and time, which is really easy to pull down from the Pi, obviously. This is just a little power button you can buy from Pomodoro or other places. It's quite useful rather than have to unplug things. So I did go a bit over the top. One of the things I wanted to do was just get back and sort of understand software engineering techniques a bit better. So I went and checked up on UML, and I checked up on design patterns, looked at some free tools and things like that. So this is my design for the clock, the Pomodoro clock, the Pi one, different types of timers. Yeah, so I'll just walk you through this really briefly. So I've got timers, different types, a work timer and a break timer. And then I've created a timer factory that creates timers on demand. And this timer sequence obviously has a series of timers. So you have your 25-minute timer, then 5-minute timer, 25-minute, 5-minute timer, that sort of thing. So and then I thought you could have a sequence manager. You got different sequences depending on what you want to do. And then you actually have a clock, obviously, and then you have displays. And I thought we could use the display, but then you could also log in by VLC or something like that and have a proper GUI display as well. So that's the OO design. I probably didn't quite use UML quite correctly, but you get the idea. So we've got the different timers here, just blowing up a little bit more. So the timer has a length and a title and description and a state, and you can start and pause it, restart it, complete. So that's just basic OO design. But I did find the exercise quite useful. The key thing here is that you actually think about what you're doing before you start doing all the coding. So you spend a little bit of time essentially designing your classes and determine what objects you want, etc. And you can do that if you like by looking at design patterns. So design patterns, I guess, have been around for 30 years, around 30 years, 28 years, something like that. There's a famous book called Design Patterns, I think it's called, by the Gang of Four, just the four guys that originally came up with the idea. And the idea is that they're using various object-oriented patterns to build things. So there's things called singletons. So that just means you only have one of those, and you make sure that you enforce that there's only one of them, just in case you do something wrong with the code. You want to make sure you don't build a second singleton. Then abstract factory produces objects. So the example here is if you have a furniture factory that produces chairs and coffee tables and sofas, and then you can have different types or different styles of chairs, coffee tables, and sofas. So you can just see here how that would work. And I've done the same thing on this side. So I've got a timer factory that's building different types of timers, work timers or break timers, and then putting them together in a sequence. So the timer sequence says, timer factory, give me, one timer, one work timer of 25 minutes, one break timer of 5 minutes, that sort of thing. So that was the idea. So with the Raspberry Pi Zero W2, just a little bit easier to do more things. So, going through the moon phases. So I just took a JPEG image of all the different moon phases and cut them down into the same size. And then I just sort of cycle through those images quite easily with Python on the Pi. I guess obviously you can do that on the Pico as well, but it just seems a little bit easier on the Pi. The little NeoPixel here indicates when it's done, so it just sort of flashes at me when the timer is finished. And then I've had various you can sort of customize your timers. So I start with just a work timer. So that's just 25 minutes, just sat normally at my desk for 25 minutes. Then it's a 5-minute break where I get a water break, a stretching break. Then the next 25-minute break, I raise my desk to a standing desk. I've got a standing desk for 25 minutes, then get some water. And then eventually, by the end of the day, I've got a 15-minute break where I do some exercise and grab a coffee, etc. So not many controls on it. So I've got reset, skip, or pause. So often if you start a timer and you're not quite ready, then you press reset to restart the timer, or you skip it if just, you've essentially been in a 1 hour meeting. So you just sort of skip through the break and go to the next thing sort of thing. So very simple. The original idea was you could change different modes and make the time more prevalent than the Pomodoro timer, and things like that. So I guess that was the other advantage of doing the OO design first. Is you sort of think of the different features and you allow for them in your design. You don't necessarily have to implement them, but then at least you've got a full idea of the what you're trying to build. So that included, I realizing as I was doing my OO design that I wanted to be able to operate from my phone, from a VNC connection or whatever, and be able to set a timer when I was at work, could have this sitting on my desk and still be able to use the Pomodoro functionality from afar. So many of you don't care about tomato timers, I'm sure. But in my experience, the software design was so there's just a few things that you might be interested in. So the software design, the OO design was definitely worth it. So the code was a lot better, as faster produces, more extensible. The design patterns really help clarify your thinking as well. So I just found there's lots of YouTube videos on design patterns and lots of useful different web pages and stuff like that. There are ones that are specifically for using with Python. So you can check those out. The UML tools are quite useful. So the one I was using is called Lucid. I'll show it to you in a minute. It does have some limits on the free version, and the Pomodoro displays are really good. So they're not super cheap, but they're not expensive either. So I guess about 12 pounds or whatever, 14 pounds, which isn't a lot of money. Obviously, you could buy something much cheaper, but then you have to add your own buttons and things like that. It's just a nice little project that was relatively easy to accomplish without a lot of soldering and other problems. It's mostly a software problem. So if I just show you, yeah. So this is the Lucid interface. So it's just a document drawer, or sorry, a UML drawer. So if you open that, so I've already got it open here. So yeah, you're just given the different types of objects. So you got your UML ones here. So you got classes and interfaces and yeah, etc. So just really quite simple. It's similar to using Visio, really. The only downside is that they limit the number of classes that you can have. So I was already running into the limit of classes you can have the free tool. So I guess it's worth checking out. You can probably find something that's a bit better that doesn't have such limitations. Yeah, it was quite useful. And then this is the website I was talking about. So it's just one of the many different patterns. So it talks you through what is a design pattern, what's the point of them, how they're classified. And there's 22 patterns. I don't know if that's the same as the Gang of Four, but it's not dissimilar. So there's not all that many. Some of them are a bit hard to understand, but you can decide for yourself, really. I guess some of them are a bit over the top for the really simple little job that you're trying to do. But it is worth taking a look if you're into software things. So I'd recommend that. And that's really it. Is there any questions on any of that?
Yeah, the Pomodoro displays are designed for a Pico. How easy was it to interface with the Pi Zero?
Well, the Pomodoro displays, they have different types. They have them for the Pi as well as the Pico. So you can connect a Pico to a Pi display and vice versa, but it doesn't make any difference. You just have to cross the wires and sort of figure it out. So it's not that difficult, but it does take some time.
Is it it's a serial interface, is it?
Yes, it's I²C.
And so all you do is configure the libraries to drive that by telling it what shape the display is, I guess. Have I got that?
Yeah, that's right. Yeah.
Oh, cheers.
Yeah. So yeah, I think in general, Pomodoro's libraries allow you to specify which pins are receiving which buttons and that sort of thing. So it can be a little bit complicated if you desperately want to use a particular GPIO for something. So you don't end up, yeah, so just be a bit careful. So it may not always be able to do what you want to do.
Okay.
Yeah, Dexter's pointing out there's a timer built into Windows 11, which I noticed. Yeah. I mean, they are quite good. The Pomodoro technique is quite good. It quite really find a difference with my concentration rate. Any other questions? Very straightforward. Anyone else have experience using design patterns or UML
Well, with regard to the Pomodoro technique, that really does look good. A lot of us have, problems with too many projects going at one time, and that's a really good way to, it looks like a really good way to kind of focus on one thing at a time and really put some time into it. So thank you.
Yeah, yeah, I did find I think I was mentioning online that it felt like a good exercise for software design. So it's relatively simple. It's sort of immediate satisfaction, so it's not too complicated, and it's not, you're not going to get tied up in soldering or trying to fit around with different bits and pieces. You just plug in the display to the Pico W or the Pi, and then you just start coding. And you just need to figure out how to do the coding. And I find these projects are quite relaxing. So you know what you're going to do, and you know how to do it roughly. There's still some twists and turns along the way, but mostly it's just about um, applying time to it. So I was using the other one, the Pico W Pomodoro, while I was building the new one. So it's quite useful to have that while I was building my new one, so I can concentrate for 25 minutes at a time. I know it doesn't sound like very long, being able to concentrate for 25 minutes, but I think you may find that you actually haven't been people find that they actually haven't been concentrating for 25 minutes at a time until you do Pomodoro. Then you realize, actually, yeah, I've been constantly distracted by my phone. Just sort of figure you have a few spare seconds, you'll check out social media or something, and or you're wasting much time.
Just want to double check with you. Did you use the customized MicroPython download for the display?
Yes, yes.
Okay.
I used the Pomodoro one.
What I'm really interested in is if anyone's tried using the generic MicroPython and driving the display, because I think the sort of the more common practice, or at least the practice I'm used to, is the generic MicroPython and then libraries for driving the devices. But I've not hunted around to see if there is a library yet for this.
Yeah, yeah. I did find it a bit. I guess I'm not that familiar, so I struggled a bit with the Pico W actually. Getting a font that I was happy with, and you have to worry about the firmware, and there's so many different versions of firmware, and getting it all sorted out. Just end up spending a lot of time in that, just getting your development system set up. And I couldn't really get I was just using Fawny, which isn't a great editor. I wanted to use PyCharm, and then it's easy to modify your code and load it onto the Pico. But then it's easy to forget to version manage as well. With the Pi, you set up your repositories, your local repository, mirrored onto GitHub, and just as that updates, you just push a version to GitHub. So I just found it. I guess it's probably just inexperience, really, but it just feels so easy just to program directly on the Pico W, and you end up sort of losing track of what code's actually on there. I mean, that's just me.
No, that's a thing.
Is it okay?
Have you tried using AI to write code?
No, I haven't. I don't know if anyone else has. Has anyone done that?
No. I've got it to write code, but I've not tried it.
Yes, I've used Microsoft Copilot a few times. When I've Googled about 5 times looking for some code to do something, I give up and use Copilot. And the code it produces is usually pretty good for small things. And then you just modify it for your own use.
Yeah, the other thing I did in this project that I didn't talk about was I wrote tests. I wrote the tests first for all the code, and then I wrote the code after that. So I guess you can only do that once you have a design. I mean, previous projects I just sort of started coding, which is a mistake. Just end up wasting a bunch of time. So yeah, definitely recommend doing both. Actually, you sort of do your design, then you sort of write a bit of a test to, when you write your code to pass the test. That sort of works quite well. Does anyone else have any other techniques they use to write better code? No. Okay, cool.
Something that might be worthwhile is there used to be, and I don't know if it's still the case, more than one environment. You can use Thonny, as you say, but there's also what's it called now? Oh, this is embarrassing. There's two others I'm thinking of. One is MP Remote, and the other is RShell. And you would just use whatever editor is your choice of editor. It's not that you're sort of constrained to use what's presented to you, like if you're using Mu for the microbit, for example. So you use your own editor, and then RShell or MP Remote will handle the downloading of the code onto the microbit. Onto the MicroPython development board. Microbit is a world unto itself, and the Python's a bit different there. So I just wanted to say that the MP Remote supports a facility where the code is effectively squirted down to the development board when you want to run it. And so you're pretty much doing all your development on your host PC, which sounds great, but they've made a dreadful hash of the user interface for MP Remote. And so if you're starting out, you might find, especially if you're starting out, you might find the other one, RShell, great deal easier. It's more along the lines of a conventional Linux tool with a clear separation between which device you're talking to with your current set of commands. You've got a clear mode switch between devices. And MP Remote, you can effectively do much the same thing. You can do a lot of your development on the host so that you're not wearing out the flash on your development board.
Right.